So welcome back to the Ergo blockchain crash course video series. In this final video, we're going to cover some examples of Ergo script and some protocols. So we're going to cover the extended Pinlock example, a section of GuapSwap version 2, and the whitelist, minting, and direct sale protocol. So the first one, extended Pinlock. So in this one, we're going to show off some super basic transaction diagrams, super basic Ergo script, and in Ergo script, we're going to cover compile time variables, accessing registers, the Blake2B256 hash function, and the sigma prop function. So when you're designing a protocol, you might want to start off with, after you know the requirements, you want to know what does it look like. So you really recommend drawing some diagrams. So in this protocol, the first stage would be the grantor, who interacts with the send transaction and would then send money to a Pinlock box. And when this box is created, it will have the money sent from the grantor and also a pin that was assigned to it in register 4 that the grantor was able to decide on. In section B, we have the Pinlock box, and that can interact with the beneficiary withdrawal transaction. So that's who the money is for, and the money in the Pinlock box will then get sent to the beneficiary's wallet. So if the conditions are correctly satisfied in the Pinlock box contract, then the beneficiary, you can spend it. So if the beneficiary knows the PIN, then they can unlock the box. And in the final section, the grantor is able to withdraw the funds from the Pinlock box if he no longer wants the beneficiary to receive the funds. Or if you sent the incorrect funds, you want to withdraw and then maybe send again. So this is what the Ergo script looks like. Like I said, it's very simple. In the first place, we start off with some comments just to understand what the contract is. What are the constants and their data types. And then any values in the registers, we want to sort of give them a name and just let people who are reading this contract know what is going on. So on the bottom left, we have the grantor PK or the beneficiary PK as conditions. So no matter what the other conditions are, either the grantor or the beneficiary are the only ones who are able to sign this transaction and therefore spend it. In the sigma prop function, we have the condition that the register of the current box of the Pinlock box must be equal to the output register as a hash. So in the R4 register, we stored the hash of the pin, and in the withdrawal transactions, the user public key box, even though the address is the user's public key, the registers can be customly defined, and the contract enforces that R4 of that box must be the hash of the pin. So if the user who creates this transaction creates an output box with the correct pin, then they can spend the Pinlock box. And that's it. So now we're going to go about talk about GuapSwap version 2. So what's the purpose of this? So this is a more complicated contract. I want to show off how to structure your Ergo script to make it more readable and understandable to others. And then in Ergo script, we're going to cover context extension variables, multiple conditions that need to be satisfied, making sure that your contract deals with multiple input boxes, and a special function called the substitute constants function. So now, what would a protocol for this look like? So version 2's protocol looks like this. So as you can see, this diagram is much more complicated than the extended Pinlock, as there are multiple stages in the protocol, 2 transactions. We use the fact that the UTXO model helps with parallelization. So the guard boxes, instead of having all of those in one guard box, we split it up into multiple ones, and each one does a specific task. And this reduces the contract complexity. We use something called Babel fees. We use context extension variables, special boxes, and then that interact with off-chain bots from Spectrum. And so there's a lot going on. So in this slide, we're going to focus just on the erg to token guard. So the second red box from the top. So in this box, what it does is it reads the amount of erg that's in the GuapSwap proxy and uses the erg allocated for token swaps for that. So whatever erg is used for erg to token swaps will then use that erg to swap for whatever token the user chose. And it'll create a erg to token box, and that box will interact with the Spectrum bots and execute the swap. So this is just a section of the erg to token guard's Ergo script contract. So here we have the GuapSwap datum. So this just has information about the particular swap the user wants to do. So in this case, it'll be all information relevant to erg to token swaps. So we used a for all sort of loop to go over all of the GuapSwap datums for each swap. So you could imagine a user's erg who wants to swap for multiple tokens, not just one. And so this would be equivalent to having multiple GuapSwap datums in this case. And we want to check that all the conditions we want are satisfied for each one of them. So when we want to know what the output index is, the box of the output box associated with erg to token swaps, and other sort of parameters we need in order to calculate the different settings we want. So for example, we need to know the payout of the miner, and then what percentage gets used for what token. Since they want to get multiple tokens, for example, we want to know what percentage of their erg is allocated to each one. So you could have, for example, 10% Neta, 50% ErgoPad, and then 40% erg. We check that the receiver addresses are correct, so this lets you send the resulting tokens to either yourself or to whoever you want. So we check, if in the ErgoHack swap box or the Spectrum swap box, if the settings are correct. And in order to do this, we use the substitute constants function. So since we already know ahead of time what the output contract should be, we can insert into the box as a context extension variable the bytes of the contract of the output box, and then we can access the constants in that contract itself and swap them for the ones that we want. So I check in this one that the public key is the same as the user, so that the swap box can be spent correctly. We check that the refund address is the same as the user's public key, so that you're able to refund your funds if you want, and that the swap box has the correct erg in it. And then we want all of these conditions to be satisfied, and so we use the olive method. So the important takeaway from this is not how GuapSwap works exactly, but how to write sort of more complicated propositions, and then more sort of advanced global methods that let you do more complicated things, like the substitute constants. So even though the Ergo script itself is really simple, we've just wrote a bunch of statements that have to be booleans. It's sort of what the interpretation, like what are you actually doing? What are you manipulating? That's where the complexity arises. You know, it's a simple language, but you can do complex things with it. And now we're going to cover the whitelist minting / direct sale protocol. There's no Ergo script for this one, but the purpose is to just look at some more advanced protocol diagrams and more design patterns, like the self-replicating box, the config box, the singleton token, the transaction chaining, and parallelization. So for minting, in the first place, a user would send money to a proxy contract. So this contract would be written in Ergo script, so an Ergo script contract that lets the user know how the funds will be spent. So it must ensure that their money will go to the next box in the next transaction, so the collection issuer proxy and what amount, that some money goes to the ErgoPad box as like a fee, and some amount goes to the transaction operator, and then the implicit miner box. In the next transaction, we actually mint a collection, so using the collection EIP, and this lets you mint whitelist tokens as part of a collection. So in the same way, if you had watched one of my previous videos about the anatomy of the Ergo blockchain, and we talked about what a token was and what an NFT and minting was, then we know that we need an issuer and an issuance box. The issuance box will contain the tokens with whose ID are the ID of the first input box in the transaction. And then after these collection tokens are minted, we then mint the the whitelist tokens. And since they're part of a collection, the IP works by ensuring that a collection token must be part of the issuer box that mints the token that you want, and thus this token will therefore be part of the collection. And we use so this collection token is used as somewhat of a singleton token in this context. In so far as its only purpose is to ensure that whatever token is minted in the issuer using the issuer box is part of its collection. So it's a way to keep track of what tokens are part of what collection, and then off marketplace, the way they would be able to know if your token was part of a collection is to check the blockchain for the same box that has the same ID as the token ID, and then if this box contains a collection token, it can do the same process and find the box with the same box ID as the collection token ID, and know what collection is a part of, read the data in the registers, and based on the EIP know what the properties of the collection were. And we used parallelization because we were able to create multiple whitelist tokens. So it branches off from the first transaction. Since only one token can be minted per transaction, we mint all of the issuer token, the whitelist tokens in each of their own transactions, and then the pink means that it's chained, so the output gets subsequently used right away as an input. And finally, we output the NFT sale setup proxy and a direct sale distribution box, which contains one of each of the whitelist tokens, as well as a direct sale sort of singleton token served as an identifier, which represents the direct sale for this whitelist token. So now we're going to cover what the direct sale is. So here, this direct sale it was created in the whitelist minting protocol section, and then it gets chained in this direct sale protocol. So a user would send money to a direct sale proxy, which ensures that the funds go to the right boxes in the right way. Then we use the direct sale distribution box as an input. It's a self-recreated box in this context because we recreate it as an output, the same contract, but what data has changed, right? We have given a whitelist token to the buyer, and so we reduce the amount of whitelist tokens in the direct sale box by 1. We ensure that the user of this minting protocol who created who wanted to use this protocol to create whitelist tokens, they get a part of the fee. ErgoPad gets a part of the fee, and again, the transaction operator also gets a part of the fee. And this process would repeat itself, where the whitelist direct sale distribution gets changed again. We check for a proxy if it exists, and this process would repeat until all of the whitelist tokens are sold, or perhaps some sale period expires. And so hopefully what I've taught with the ErgoScript fundamentals and then the blockchain concepts and UTXO concepts, you're able to understand what was going on in these protocol diagrams. So what's next? So you've watched this video. What do you do next? So you could read more papers if you wanted, where it covers more advanced concepts about the blockchain, like ErgoScript and ErgoTree, how it's defined as a language. You can learn about the AVL tree implementation within Ergo, how Nipopals work, and just more advanced topics. You can read the Ergo Manifesto if you haven't already. It's a good way to indoctrinate yourself into Ergo. There's Ergo Docs, the official website, docs website for Ergo. It's a good reference to use also while you're working on a project, along with the Bible of the language specification for ErgoScript. There's also Deco, which I actually participated in myself almost a year ago, and that was my first exposure to the Ergo blockchain more in depth. It's a great way to interact with other students who are interested in learning the same things. Just talking to people is really cool. You get to learn with some homeworks or projects if the course requires it. You can get help from experienced developers. It's a good opportunity to network with other people, find out what other people are interested in working on in the ecosystem. And there are different courses like the layman and advanced courses, and might even open up opportunities for you to internships with other projects. There's also DAppStep, which is another good video tutorial series on UTXO and ErgoScript concepts, more geared towards people interested in blockchain development using the web browser. So you'll learn about like the how to interact with Ergo using JavaScript. You could learn cryptography if you wanted. Maybe even do your own research and start trying to build your first project if you haven't already. Thanks for watching. This is it for the Ergo Crash Course video series. I hope you liked it. If you found it informative, please consider checking out Deco and ErgoPad as well. Thanks.